Imagine for a second walking into this highly expensive, totally state-of-the-art kitchen.
Okay, I'm picturing it.
Right, so you have all your ingredients prepped, you are completely ready to bake a cake, and you go to turn on the oven.
Makes sense so far.
But instead of a temperature gauge or, even like a digital screen with clear presets like bake or broil,
Right.
you are just faced with this completely blank, totally unlabeled dial.
Oh, that sounds like a nightmare.
It is. So you turn it to, let's say, position number 3. And you just have to magically know that 3 translates to exactly 350 degrees.
Yeah, that is an inherently flawed design. I mean, you were forcing the user to rely on external memorization,
Yeah.
right, rather than the system actually communicating its own state. The mental overhead there is completely unnecessary.
Exactly. And it's terrifying when it comes to, operating a 500-degree appliance in your house.
Oh, absolutely.
But for you, listening to this right now, this scenario is actually highly relevant. Because this is precisely how a staggering amount of the software running our digital infrastructure is engineered today.
It really is. It's everywhere.
Welcome to the deep dive. Today, our source material is this highly specific transmission that was published on August 10th, 2026.
Right, by a developer who goes by the name Ang.
Yep. And it's titled Notes-on-Haskell-Programming Part 209, Refactoring CLI Verbosity for Better Type Safety.
Which I know on the surface, a refactor of a command line interface verbosity flag sounds like this incredibly micro-level, totally niche update.
Like, why are we doing a whole deep dive on this, right?
Exactly.
Yeah.
But Ang's notes actually provide this complete masterclass in building resilient, error-proof systems.
Yeah, it really scales up.
It does. By examining how this one developer changes the way a program tracks its own loudness, basically, we get a front-row seat to this massive philosophical shift in software architecture.
So let's set the baseline for what Ang was actually trying to fix here. The program in question is a command line tool.
Right.
And like most CLI tools you'd use in a terminal, it has a way for you, the user, to ask the program to explain what it is doing behind the scenes.
Yeah, we are talking about the classic -v flag.
Exactly. You type a single -v for verbose output.
Right. And you type -vvv for more detailed logs.
And -vvv to get just the maximum amount of debug information dumped right to your screen.
Yeah, the user interface.
And I want to unpack this from an architectural standpoint for a second, because I mean, if I am just throwing a quick script together on a Friday afternoon, using an integer to count the number of V's seems like the most logical, frictionless way to solve the problem, right? Like 1 V equals 1, 2 V's equals 2.
It feels very natural at first.
So why exactly is that considered such a dangerous practice when you move into a larger code base?
So it is really a question of domain modeling. When you use an integer to represent a finite set of states.
Like our 4 specific logging levels here.
Right. You are basically using an infinite container to hold a very small, strictly defined concept.
Oh, I see.
Because a variable categorized as an integer in a program doesn't just hold the numbers 0, 1, 2, or 3. By its mathematical definition, it can hold 5.
Right.
It can hold 42. It can hold, -99.
Wow. So you are just leaving this massive backdoor wide open for the program to enter a completely invalid state.
Precisely. You are relying entirely on human discipline, on developer discipline, to just never accidentally pass an invalid number to that function.
Which is a tall order.
It is, and Ang explicitly calls this out. They say it makes the system fragile and hard to read, because imagine you join this project a year later.
Okay.
Yeah. You open a file, and you see a function that requires a verbosity parameter set to just the number 3.
Just a floating 3 in the code.
Right. Because it's just a raw integer, the code itself gives you zero context about what 3 actually means in reality.
Right. So now the developer has to literally stop coding, pull up another file, or try to track down some ancient documentation just to figure out the context.
Exactly. It is a mental tax.
It really is.
It's this continuous cognitive load.
Yeah.
You're basically forcing the human brain to act as a translation layer. And, humans make mistakes.
All the time.
Accidental logic errors, like maybe passing a 4 to a logging function that only literally knows how to process levels 0 through 3. That becomes this constant looming risk in the background.
Because the code base itself has no structural defense against that kind of human error.
None at all. It relies purely on hope.
And hope is rarely a sustainable strategy for software engineering.
No, it is not.
So Ang decides to just completely eliminate the ambiguity, which leads us right to the core of this whole refactor. They replace those raw integers with what's called an algebraic data type.
Yes, an ADT.
So Ang completely rips out the numbers 0, 1, 2, and 3 from the internal logic of the verbosity system entirely.
It's a clean slate.
Yeah, and the new definition reads like this. It says data verbosity equals quiet, pipe, normal, pipe, verbose, pipe, debug.
Right.
I look at that, and it is just a night and day difference.
It really is.
If the old system was that infinite unlabeled dial, this new one is a highly specific four-way switch. The labels are basically etched directly into the syntax of the code.
And we should probably clarify what an algebraic data type actually means in the context of a functional language like Haskell specifically.
Yeah, that's a good point.
Because in older languages like C or Java, developers will often use enums to create these named labels. But under the hood, the compiler is frequently just treating those labels as zero-indexed integers anyway.
Wait, really? So they are just integers wearing a disguise?
Exactly. They're just pretending to be words.
Ah, so you could still accidentally do math on them or run into those same boundary errors we talked about?
Often, yes, you can. But in Haskell, this ADT is a mathematically distinct, entirely new type.
Okay.
Quiet isn't a zero in disguise. Quiet is simply quiet.
Wow.
You have defined this completely new universe where only those four specific things exist, and you have eliminated that dangerous translation step entirely.
That is so clean. And right below that declaration, Ang includes this other line that dictates how this new type behaves.
Right, the deriving line.
Yeah, it says deriving eq, cho, enum, bounded. And I want to break this down because this seems to be where the compiler is really given its marching orders.
It absolutely is.
So I assume EQ just stands for equality, like giving the program the ability to compare two verbosity levels to see if they're the exact same.
That's correct. Without EQ, the compiler literally wouldn't know how to evaluate a statement asking if, say, the current state is equal to debug. It would just throw an error.
Makes sense. And show likely instructs the compiler on how to convert these distinctive types into readable strings so they can actually be printed out to a log file or a terminal screen.
Yes, exactly. It gives the abstract type a concrete string representation,
Ah.
but then we get to enum and bounded.
All right.
And these two are really the structural pillars of this specific refactor.
Let's look at bounded first, because the word itself obviously implies borders. This must be what establishes the absolute floor and ceiling of our new four-way switch.
It is. When you drive bounded, the Haskell compiler explicitly registers that quiet is the absolute minimum state possible,
Okay.
and debug is the absolute maximum state. There is literally no concept of anything existing beyond those two boundaries.
Which fundamentally changes the relationship between the developer and the compiler, doesn't it?
It transforms it completely.
Because if I try to pass a level 5 verbosity to a function that expects this new verbosity type now, the code won't just fail when I run it. It will actually refuse to compile in the first place.
Exactly. The compiler becomes this incredibly strict co-pilot.
I love that.
It looks at your code, it sees you trying to pass something outside of those four declared states, and it basically says, I only understand quiet, normal, verbose, and debug. I cannot physically build this program with a state that doesn't exist.
That is amazing. You have taken a system that relied on fragile human memory and replaced it with a system where doing the wrong thing is quite literally impossible.
That is the exact type safety Ang is talking about in the title of their notes.
But that brings up the other derivation they used, right? Enum.
Yes, enum is crucial here.
Because if these aren't integers anymore, like we said, if quiet is just quiet, how does the program know what the quote-unquote next level up actually is?
And that is the exact problem enum solves. Deriving enum tells the compiler that these four distinct states do exist in a specific sequential order.
Okay.
It allows the program to safely map these concepts to an index behind the scenes without permanently turning them back into raw integers in the main logic.
And that sequence is critical because we still have to deal with the outside world.
Always the hardest part.
Right. We have this pristine, beautifully bounded internal system, but the user interacting with the command line is messy and unpredictable.
Very messy.
The user is just passing us a string of literal V's, and if someone is frustrated because a script keeps failing, they might just mash the keyboard and type -VVVVVVV.
Oh, I've done it. We've all done it.
Exactly. So how does the program safely translate that chaotic, totally unbounded string of text from the user into this strict four-state internal system without just crashing entirely?
This is where we see the bridge between the messy external world and the perfectly typed internal world. Ang introduces a specific parser called Verbosity option to handle this exact translation.
Right, so the parser's job is basically just to count the repeated V flags.
Yes.
But it has to apply a limit. And Ang uses this very specific line of code to quote-unquote clamp the user's input. And this is where we really see all those derivations we just discussed put into action.
It's a beautiful piece of logic.
The code is, let me read it here. It's to enum.min, then in parentheses, from enum, and then another set of parentheses, max bound :verbosity.
I know, that sounds like a mouthful.
It really does. It's a lot of parentheses.
Let's trace the data as it flows through that pipeline. It's easiest if we read it starting from the inside out.
Okay, let's do it. So let's say our frustrated user types 6 Vs. The parser counts them up, so we are currently holding the raw integer 6.
Right. Now, the innermost part of that equation you read is max bound :verbosity.
Okay.
Because we derived bounded earlier, the system evaluates that specific phrase as debug.
Got it, because debug is our ceiling.
Exactly. But we have a problem. The next function in the pipeline moving outward is min, which is trying to find the minimum between two values.
Right.
It needs to compare the user's integer 6 against our max bound. But you cannot mathematically compare the integer 6 to the abstract concept of debug. There are different types.
Which is exactly where from enum steps in.
Precisely. Because we derived enum, the from enum function can temporarily translate the concept of debug into its structural index, which happens to be 3.
Oh, I see. So now the min function is simply comparing the user's integer, which is 6, with our max index, which is 3.
Exactly.
And the minimum of those two numbers is obviously 3. But wait, we can't just hand a raw 3 to our internal system, because our internal system only speaks the language of our algebraic data type now.
So we hit the final step on the far left of the pipeline, to enum.
Right.
It takes that integer 3 and safely translates it right back into the strict verbosity type. So the output of the entire pipeline is the safe, bounded concept of debug.
That is so clever. But okay, I have to play devil's advocate for just a moment here.
Go for it.
I look at tunum, min from enum, max bound. I mean, it is a very elegant, functional pipeline.
It is.
But wouldn't it be easier and perhaps a lot more readable for a beginner to just write a simple if statement?
You think so, yeah.
Like something like, if the user input is greater than or equal to 3, then just return debug. Why go through this whole functional translation dance?
It's a great question. An if statement definitely solves the problem for today, but it creates technical debt for tomorrow.
How so?
Well, imagine that 6 months from now, the development team decides they actually need more logs. You want to add a 5th verbosity level called trace.
Oh, okay. If I use my if statement, I would have to go manually hunt down that parsing logic, change the greater than or equal to 3 to a 4, and just hope I didn't introduce a typo or some weird off by 1 error.
Exactly. But with Ang's functional pipeline, you don't touch the parsing logic at all.
Wait, really?
But not one bit. You just add trace to the original ADT declaration at the top of the font.
Oh.
Because you derived bounded and enum, max bound just automatically evaluates to trace now.
Oh, that's brilliant.
Right, and from enum automatically evaluates to sur4. The entire pipeline adapts dynamically based entirely on the shape of the data type itself. It's completely resilient to future changes.
Okay, that completely justifies the approach. You are essentially front-loading the architecture so that future feature additions require literally 0 mental overhead.
That's the goal.
It's like having a bouncer at the door of a really exclusive venue.
I like that analogy.
The venue is our perfectly bounded ADT. It has a strict maximum capacity of exactly 4 states. And then this chaotic user shows up demanding a table for a party of 10.
Right.
The bouncer, which is our clamping pipeline, doesn't just reject the user outright and crash the program. The bouncer simply says, I am capping your party at maximum capacity. You get 4 seats.
Exactly. It protects the structural integrity of the internal system while still safely accommodating the user's wild request.
It perfectly bridges the unbounded nature of human interaction with the strictly bounded rules of the type system.
It's incredibly elegant.
It really is. So having secured the internal logic and, fortified the front door against the user, Ang's nodes detail one final challenge.
Right, the integrations.
Because the program doesn't just exist in a vacuum, right? It has to communicate its verbosity levels to external tools. Specifically, this CLI interacts with something called Pandoc.
Yes, and Pandoc has its own completely separate internal logging system.
Which means we need a translator.
Exactly. And this is where we really see the ripple effect of Ang's refactor. The benefits of that ADT we build start bleeding out into every single integration point in the codebase.
Ang actually provides a snapshot of the old codebase to show how the program used to map its integers to Pandoc's log levels. And it was essentially just this fragile lookup table.
A classic magic number trap.
Yeah, it basically said, if our integer is 0, send Pandoc an error.
Right.
If our integer is 1, send Pandoc a warning. And then it had this weird catch-all line at the end, underscore equals INFO.
Ah, right. So in Haskell, that underscore acts as a wildcard pattern match.
What does that mean exactly?
It basically translates to literally anything else that hasn't been explicitly handled above this line, just do this.
Oh, wow. Which totally exposes the massive vulnerability of using integers in the first place.
Exactly.
Because if the integer was 2, it sent INFO. But if the integer somehow became 99, it still just sent INFO.
Yep.
If the integer was negative 400, it sent INFO. The compiler had absolutely no way of knowing if those numbers were intentional or if they were the result of some catastrophic bug happening somewhere else in the code.
Right. It just blindly swallowed all those errors right into the wildcard.
That is wild. It's like the ultimate manifestation of the magic number trap. The system is just operating completely in the dark.
It is. Now, contrast that old fragility with the new mapping Ang wrote, which is a function they called Pandoc Verbosity.
So the new function completely ditches the integers and those dangerous wildcards.
It throws them out entirely.
It just maps our explicitly named states. So quiet translates directly to Pandoc's error. Normal translates to warning. And it explicitly states that both verbose and debug translate to INFO.
And the critical architectural difference here is what's called exhaustive pattern matching.
Exhaustive.
Right. Because the compiler knows our verbosity type only has 4 possible states. It forces the developer to handle all 4 of them. No more, no less.
Whoa. Meaning, if someone later adds that hypothetical trace level we talked about earlier, the compiler will look at this Pandoc verbosity function and actually throw an error warning the developer that they forgot to tell Pandoc how to handle trace.
Exactly. The compiler catches the omission before the code ever even makes it to production.
That is so powerful.
It really is. The old wildcard underscore just allowed for silent failures, but the ADT ensures loud, immediate, helpful failures right during the build process.
Ang describes this new mapping as explicitly self-documenting, and that phrase really crystallizes for me when you look at how the automated tests were updated in the notes.
Yeah, tests are often the best documentation a codebase actually has.
Right. So in the old version, a test was written to say, parses-VVV as verbosity 3.
Again, requiring the reader to know the secret magic number code.
Exactly. But the updated test, it reads parses-VVV as debug verbosity.
It's just plain English.
The cognitive friction is just 0. You don't need a manual. You don't need to trace variables through 5 different files to understand what 3 means.
Right.
The code tells you exactly what it's doing, and the compiler mathematically guarantees that it's actually telling the truth.
Which perfectly synthesizes and answers Ang's own concluding question in the notes, which is simply why this matters.
Yeah, why do all this work?
Exactly. Taking the time to replace integers with explicit constructors removes that mental tax of translation. The developer's brain is finally freed up to focus on the actual business logic of the application, rather than just babysitting raw integers all day to make sure they don't step out of bounds.
Right.
The code becomes clean, it becomes highly readable, and it becomes inherently hostile to bugs.
It is future-proofing in the truest sense of the concept.
It really is.
Let's trace the arc of what we've covered today, because we started with a system heavily reliant on the incredibly fragile assumption that a raw number meant what the developer intended it to mean.
An infinite container being used for a strictly finite problem.
Exactly. And we followed Ang's process of stripping away that ambiguity, establishing a perfectly bounded universe using an algebraic data type.
Right.
We explored how derivations, like enum and bounded, provided the structural metadata necessary to construct that mathematically sound clamping pipeline.
Our bouncer at the door.
Our bouncer, safely translating chaotic user input right into our strict internal types.
And then we saw how replacing wildcards with exhaustive pattern matching made external integrations completely bulletproof, literally forcing the compiler to verify our logic at every single step.
The technical mechanics are brilliant, but I think what elevates this from just being a neat programming tutorial to a real architectural philosophy is how broadly this core lesson applies.
Oh, absolutely.
It forces you to look at systems far beyond just a Haskell codebase. For you, the listener, navigating your own workflows or complex projects, it really begs the question, where are you relying on magic numbers?
Yeah. Where are you using an infinite container, like a vague policy or an undocumented process, to manage a situation that actually requires strict, clearly defined boundaries?
Where do you have unlabeled dials in your infrastructure, technical or otherwise, just waiting for someone to accidentally turn them to a 5 when the system is only designed to handle a 3?
It's a recipe for disaster.
And more importantly, where could you replace that fragile ambiguity with explicit categorized states?
Taking it a step further, Eng basically proved that explicit self-documenting code creates systemic resilience, right?
Right.
It
Right.
completely removes the necessity for assumption. If we apply that exact same mindset, a kind of human-type safety, if you will, to our daily communication, the implications are actually fascinating.
Oh, I see where you're going with this. Like bounding our language to prevent invalid states in human interaction.
Exactly. Think about it. How much operational friction, how much daily misinterpretation and actual project failure stems purely from the fact that our instructions rely on implicit, fragile assumptions?
A lot of it, honestly.
Right. So if instead of telling a team member, hey, make this a level 3 priority.
Which is a completely subjective magic number.
Exactly. What if we established an explicit vocabulary instead?
A bounded set of priorities that means the exact same thing to literally everyone in the room, where ambiguity is just physically removed from the workflow entirely?
Yes. It is the difference between hoping someone inherently knows how the oven works and engineering a dial so incredibly clear that they cannot possibly burn the house down.
It is a deceptively simple shift in structure, but it totally changes the entire foundation of how a system operates.
It really does.
Well, that brings us to the end of today's deep dive. We will leave you to examine the dials in your own systems and see what might need a permanent label. Catch you next time.